Write in a factor of 28 that is a prime number. So factors of 28 are 4, 7, 2, 14, 1, and 22. So 7 is a prime number, 2 is a prime number. So you can write either of these. Question 2 says simplify 4y squared plus 3y minus y squared plus 2y. So we collect the like terms, 4y squared minus y squared and 3y plus 2y. So that's 3y squared plus 5y. Question 3 says shade 2 more small squares to make a pattern with 2 lines of symmetry. So what we can do is we can shade this square and we can shade this square. So we will have one line of symmetry like this. And the other line of symmetry is going to be like this. So this way we have 2 line of symmetries for this shaded pattern. Question 4 says calculate 20.24 minus cube root of 30 over 6.5. Give your answer correct to one decimal place. So cube root of 30 is going to be 3.107. So we divide this by 6.5. So now we subtract 20.24 and 3.107, which is 17.133. Divide that by 6.5. That gives us 2.63. Round that to one decimal place. So 2.6 is your answer. Question 5 says a pattern is formed by 3 congruent rectangles. Each rectangle is a rotation of 90 degrees around one vertex of the rectangle next to it. The point A has coordinates 2, 5. The point B has coordinates 4, 1.5. Work out the coordinates of points C and D. So if the congruent rectangles, that means the sides of the rectangles measure exactly the same. So this over here, x is 2 and this is 4. That means this length is 2 units. So is this. So this is also 2 and 1.5. Why 2, 1.5? Because they're sharing the same y value. And over here, it's going to be 4, 5 because they're sharing the same y value and x value is being shared by point B. Now, this is also 2. This is also 2. This is also 2. This is also 2. So if we go 2 units down from 5, then that's going to be 4, 3 over here. And from 3, we're going to 1.5. So that means this is 1.5 units. So total distance over here is 3.5. So this is also 3.5. This is also 3.5. And this is also 3.5. Now, since we figured out that this is 4, 3, this point, so that means this will have the y coordinate of 3. And for the x coordinate, from x equals to 4, we're moving 5.5 units to the right-hand side. So 4 plus 5.5 is going to be 9.5. So this point over here is 9.5, this one. So 2 units back, C is going to be 7.5 and 3. And for D, x value is going to be 9.5 because that's vertically above this one. And for the y value, from y equals to 3, we're moving up 3.5 places. So that's going to be 6.5. So as you can see, D is 9.5 and 6.5, and C is 7.5 and 3. These are the coordinates of points C and D. The key rule for this is that congruent shapes have the same lengths for their sides. So whatever the length is for one rectangle, the other rectangle will also have the same length. Whatever is the width for the first rectangle, the other rectangles will have the same width as well. And since they've given us point A and B, so when you walk that many units from one point to the other point, you will be able to figure out, what is being added to get the next point, what is being subtracted. When you're moving horizontally, you're changing your x coordinate. When you're moving vertically, you're changing your y coordinate. So these are the key rules that you need to remember when trying to figure out coordinates for such composite shapes. Then question 6 says, each week Nisha is paid $12 per hour for the first 40 hours that she works. She's paid 30% more per hour for any extra hours that she works. 1 week Nisha works for 45.5 hours. Calculate how much she's paid that week. So $12 per hour for the first 40 hours. So 12 times 40 plus she's paid 30% more for any extra hour that she works. So we need to find 30% of 12. So 30% of 12 is going to be 3.6. So 12 plus 3.6, which is 15.6. She's paid $15.6 for any extra hour that she works. So 15.6 times x. So 1 week Nisha works for 45.5 hours. Out of those 45 hours, 40 hours are the first 40 hours for which she's paid $12 per hour. So now for the extra 5.5 hours, which is going to replace x, for these extra 5.5 hours, she will be paid $15.6. So now this will give us her total pay. So we do 12 times 40, which is 480, plus then we do 15.6 times 5.5, which is 85.8. Add the two, and she gets $565.8. That's how much she earns. Question 7 says the table shows the age and mass of each of 10 babies. Complete the scatter diagram. The first 6 points have been plotted for you. 9 and 4.6 are going to come. One, two, three, four, 5. That's 6. That's 9, 4.6. Then 7, 4.5. That's going to be this one. 1, 2.5. Is this. And 11, 5.3. is this one. So these are our points on the scatter diagram. Then it says what type of correlation is shown in the scatter diagram. So if we go back to the plotted points, we can see that as the value of age is increasing, the mass is also increasing, which means it's a positive correlation. When both the quantities are increasing, it shows positive correlation. When one quantity is increasing and the other is decreasing, that shows negative correlation. So positive. On the scatter diagram, draw a line of best fit. Then using a line of best fit, find an estimate of the mass of a 14-week-old baby. Okay, first let's draw the line of best fit. For the line of best fit, you have to make sure that you have equal number of points above and below the line. So if we choose these points, we have 1, 2, 3 points above the line and we have 4 points below the line, which seems fine, where it's a balanced line. So 14-week-old baby, you draw a line from 14 towards the line of best fit. And that brings us at 6.1, 2, 3, 4. 6.4. This is the weight I'm getting for a 14-week-old baby. 6.4. Question 8 says the scale drawing shows the positions of boat A and boat B. The scale is 1 centimeter, represents 0.5 kilometers. Find the actual distance between boat A and boat B. So for this, what you'll do is you will connect boat A and boat B with a straight line first. Then what you will do is you will measure your distance using a ruler. Now, whatever that distance is, let's say it's 4 centimeters. Let's say I'm assuming, since I can't measure it online like this, so I'm assuming that the distance is 4 centimeters. So what you will do is, since in the scale 1 centimeter equals to 0.5 kilometers, you will multiply your measured distance with 0.5, and that would give you the actual distance. So 4 times 0.5 is 2. So 2 kilometers, based on my assumption that this is 4 centimeters, would be the actual distance. Once again, for you, you will connect point A and point B with a straight line using a ruler. Then you will measure that distance from the ruler, and whatever that distance is, you will multiply that by 0.5 to get the actual distance. Lighthouse L lies to the east of boats A and B. L is 4.4 kilometers from boat A and 3.3 kilometers from boat B. Using a ruler and a compass only, construct and label the points of L. So, since it's on the east of A and B, that means it's going to be on the right-hand side over here. Now, they told us that L is 4.4 kilometers from boat A. So we know that 1 centimeter is equal to 0.5 kilometers based on our scale. So to convert 4.4 kilometers into centimeters, we will divide 4.4 by 0.5, and that will give us 8.8 centimeters. This is for A. Then for B, what you will do is you will divide 3.3 by 0.5 to find the distance on the map. So 3.3 divided by 0.5 is going to be 6.6 centimeters. So now what you will do is you will take your compass. You will first open the compass to 8.8 centimeters. You will put it at point A, and then you will draw an arc with the compass being 8.8 centimeters long. And you will make an arc over here from point A towards the right-hand side because the lighthouse is on the right-hand side. Once again, you will open your compass to 8.8 centimeters. You will put it at the vertex A and draw an arc, which is going to be on the right-hand side. That will mark the position of the lighthouse from point A. Then you will again open your compass to 6.6 centimeters this time, put it at vertex B, and draw another arc towards the right-hand side to mark the position of the lighthouse from point B. So basically, these are going to be your arcs, something like this. So your arcs will be intersecting at a point. The point where they will be intersecting, that's going to be your position of the lighthouse. So once again, I'm going to repeat it another time. You open your compass to 8.8 centimeters to draw the arc from point A. Then you open your compass to 6.6 centimeters to draw the arc from B. Intersection of the two arcs shows us the position of the lighthouse. You mark this like this and label it as L. That's how you draw the construction for this. Then question 9 says write 0.00709 in standard form. So this right now is your ordinary number. So in standard form, you can see that the number would be the number times 10 to the power of something. So to figure out what that 10 to the power of something will be, what we do is we move the decimal 1, 2, 3 places to the right-hand side. Now, why are we moving it just 3 places? Because when you're writing a number in standard form, our first digit has to be a non-zero digit. So that's why we stopped at 7, because 7 is the first non-zero digit that we get in this number. So it's going to be 7.09 times 10 to the power of negative 3. Now, why is it 10 to the power of negative 3? It's 10 to the power of negative 3 because you're moving the decimal 3 places to the right-hand side. And when you would rewrite this in ordinary number, you would move the decimal 3 places to the left-hand side. So the order is opposite when you're converting from ordinary to standard and standard to ordinary. When you're converting from ordinary to standard, if you're moving the decimal to the right-hand side, that means the power will be negative. And if you're converting from standard to ordinary, if the power of 10 is positive, you're moving it to the right-hand side. So as you can see, the order is opposite. Then work out 4 times 10 to the power of 4 whole square. So what you will do is you will distribute the square, 4 square times 10 to the power of 4 whole square. 4 square is 16. Whenever we have a power outside the bracket and inside the bracket, we multiply the powers, which is one of the rules of indices. So it's going to be 10 to the power of 8. Now, once again, this at standard form. And like I told you, in a standard form number, your first digit before the decimal has to be a non-zero digit. Over here, we have no decimal. So to write the decimal, you need to remember that every whole number has a decimal at its end. 16.0 is the same as 16. So we write 16 as 16.0 times 10 to the power of 8. Now we move the decimal 1 place to the left-hand side because the first number before the decimal has to be a non-zero digit. And before the decimal, there only has to be one number, just by the way. You can't have 2, 3 numbers before the decimal. Like you must be thinking that 16.0, it's a first number is a non-zero digit. It doesn't work like that. Your decimal comes after the first digit, and that first digit has to be a non-zero digit. So that's going to be 1.6 times 10 to the power of 9. Since we move the decimal 1 place towards the left-hand side, we add 1 to the power. So that's your answer. So in question number 10, it says, draw the image of a triangle A after reflection the line y equals to 1. So first we draw a line at y equals to 1. Now, let's reflect the shape A in this line. So this point is 1 unit from the mirror line. So that means the same happens on the other side. It's going to be 1 unit from the mirror line on the opposite side at the same x value. Similarly, this point is 2 units. So again, we go 2 units. So this is where this is. And this one is 4 units. So 1, 2, 3, 4. This is your third point. So I'm going to connect these. And as you can see, this is a reflection of triangle A in the line y equals to 1. Then triangle A after translation by the vector negative 6, 1. So in a translation, what we're doing is we're moving the shape up or down, left or right based on what the translation vector is. The first number in the translation vector is your x value and the second is your y value. So when it says negative 6 for x, that means we're moving 6 units to the left-hand side. So 6 units to the left. And for y, it's 1 unit up because it's positive. If it was negative y, we would be moving 1 unit down. So x is going 6 units to the left side. So that means this point comes over here. This point will come over here. And this one will be over here. Now this is just for the horizontal translation right now. Since it's going 1 unit up, so that means we shift all of these points 1 unit up. So this over here, and this over here. Let's remove these. This is your translation. Now, as you can see in both the reflection and the translation, the shape of the object did not change. Why? Because we're not enlarging it. So the shape will remain same. In the reflection, what happens is that the direction of the shape changes. In a translation, the direction doesn't change, only it moves away from it. So it can be like any way from the original shape depending on what the translation vector is, but the size of the shape will remain the same. The direction of the shape will also remain the same. And for the reflection, size will remain the same, but direction of the shape changes. Then it says, describe fully the single transformation that maps triangle A onto triangle B. So let's first begin with highlighting corresponding points on both the shapes. So if we notice, if we rotate this shape 90 degrees anti-clockwise, going to be in this direction. So then it's going to look like this, which is exactly what we have for this. So we have identified what the rotation is. Now we need to identify what the center of rotation is. For the center of rotation, what we do is that the corresponding points, like the horizontal and vertical distance of the corresponding points, swaps for the original image and the rotation. So for example, if from the center of rotation, the horizontal distance is 2 for this point, so now it's going to be 2 for the vertical distance for the rotated image. So that's how we swap it. So over here, if we pick point 30, this will have a horizontal of 1, vertical of 2. This will have a vertical of 2 and horizontal 3, so that's not working. If we pick 3, -1, it's that 1 horizontal distance and 3 vertical distance from the center to this point. And for the rotated image, now it's 1 vertical, which was 1 horizontal for this, the opposite 1 vertical, and 3 horizontal, where 3 was vertical for this. So as you can see, for point 3, -1, the horizontal and vertical distance is swapping. for the highlighted point. Let's try that with the other points as well. Compare this and this. So this point is 6 vertical. And this is 6 horizontal, so that works. Now for the third point, it's 2 horizontal and 4 vertical. This is 2 vertical, 4 horizontal. So that means this is our center of rotation. So center of rotation is 3, -1, and your rotation is 90 degrees anti-clockwise. Remember, for the center of rotation, your distance of the original point and the rotated point, you swap the horizontal and vertical distance that it has from the center of rotation. 90 degrees anti-clockwise rotation about the center, 3, -1. That's your answer. Question 11 says Middle invests $1,500 at a rate of 4.2% per year compound interest. Calculate the value of the investment at the end of 5 years. So compound interest has the formula of principal amount times 1 plus rate of interest over 100 to the power of t. Principal amount is 1,500. Rate of interest is 4.2, so 4.2 over 100 to the power of 5. And that is going to give us 1,842.59. So you can round that to 1 decimal place. So $1,842.6. Then it says, Tanshi invests some money at a rate of X% per year compound interest. At the end of 11 years, the value of investment has doubled. Calculate the value of X. So if at the end of 11 years, the value of the investment has doubled, so we're saying initially he's investing P. So at the end, it's going to be 2P. So 2P equals to P times 1 plus X over 100 to the power of 11. Once again, they haven't given us what money he's investing. He invests some money. So we assume that that some money is P. And then they say at the end of 11 years, the value of the investment has doubled. So that means it's going to be twice of that P. So 2P equals to P times 1 plus X over 100 to the power of 11. Divide 2P by P. And this is 1 plus X over 100 to the power of 11. That's 2. Next, what we do is we take the 11th root on both sides to get rid of the 11 power on the bracket. So now 2 to the power of 1 divided by 11 is 1.065. Remember, if it's the root of something like 11th root of 2, that's 2 to the power of 1 over 11. So that's what you would plug in your calculator to find the value of the 11th root of 2. That's 1.065 equals to 1 plus X over 100. Finding the 11th root of 1 plus X over 100 whole power 11 gets rid of the powers. So now it's 1.065 minus 1 equals to X over 100, which is 0.065 equals to X over 100. Cross multiply the 100 with 0.065, and that gives us 6.5% for X. That is your rate of interest for this. Question 12 says a cone has sloping edge 12 centimeters and base radius 5 centimeters. Calculate the total surface area of the cone. So cone basically looks like this. We have a curved surface area and then we have a circular base. So the circular base has an area of pi r square and the curved surface area has a formula of pi r l. So total surface area is pi r squared plus pi rl. Radius is 5, so pi times 5 square plus pi times 5 sloping edge is the curved length, the slant height. That's 12. So that's going to be 12. So 25 pi plus 60 pi, which is 85 pi. Multiply 85 with pi, and that's going to give you the value for the total surface area, 267.03 centimeters square. That's the total surface area of this cone. Question 13 says the table shows the first 5 terms of sequences A, B, and C. They have given us the first, second, third, fourth, and fifth term for all 3 sequences. They want us to figure out the nth term. So in the first sequence, let's try to find the common difference if there is any. So we have 5, 12, 31, 68, and 129. So 12 minus 5 is 7. 31 minus 12 is 19. 68 minus 31 is 37. 129 minus 68 is 61. Now between 19 and 7, there's a common difference of 12. Between 37 and 19, we have a difference of 18. And between 61 and 37, we have a difference of 24. Now between 12 and 18, there's a difference of 6. And between 24 and 18, there's also a difference of 6. So as we can see, first difference was not common, second difference was not common. This is the first difference. This is your second difference. Third difference. So if the third difference is common, that means it's a cubic sequence. If the second difference is common, that means it's a quadratic sequence. And if the first difference is common, that means it's a linear sequence. First difference common, that's linear. And second difference common, that's quadratic. Third difference common gives us a cubic equation. Now, cubic would mean that, let's assume that the nth term is n to the power of 3, n cubed. So if we use n cubed and we match this with the given terms in the sequence, the first term we'll get is 1, because 1 cubed is 1. But over here we have a 5. How can we turn the 1 into a 5? If we times 1 by 5, that's going to give us 5, right? So let's assume that the nth term is now 5n cubed. So if we use 5n cubed and try to find the second term, 5 times 2 cubed would be 5 times 8, which is 40. That's not the same as 12, so that means 5n cubed is not the right nth term. So let's circle back to n cubed again. So now how can we turn 1 into 5? We can add 4 to n cubed because 1 plus 4 would be 5. So if we find the second term using that, 2 cubed plus 4 would be 8 plus 4, that is 12, which is the same as the term in the sequence. Okay, let's use that again to find the fourth term. So that's going to be 4 cubed plus 4. 4 cubed is going to be 64, and 64 plus 4 is 68. That once again matches with the term given as sequence, which means our nth term for the cubic sequence is n cubed plus 4. So for this, just remember you can start with n squared. If it's a quadratic, if it's cubic, you can start with n cubed. And then you can just like put in the first term, second term, third term, and see how you can change your nth term to create the right formula that would give us the terms in the sequences. Now moving on to the second sequence. In the second sequence, they've given us fractions, and it says that the first term is 10 over 3, then it's 9 over 4, 8 over 5, 7 over 6, 6 over 7, and so on. So if you look at the numerators, we can see that it's 1 less than the previous term. We subtract 1 from 10, so that gives us 9, then subtract 1 from 9, that gives us 10, and so on. Whereas in the denominator, the trend is opposite. You're adding 1. So for the numerator, if we write the terms down as a sequence, we can see that they have a common difference of -1. So it's going to be a linear sequence for the numerator. So whatever the common difference is, you always multiply that with n. So over here, since the common difference is -1, we multiply -1 with n. So that gives us -n. Now let's assume that the nth term is -n. So if on the first term, that's going to be -1. Now -1 is not the same as 10. What can we do to -1 to turn it into a 10? We can add 11. So if we assume that the nth term for the numerator is -n plus 11 or 11 minus n, let's find the second term. That's going to be -2 plus 11, and that's 9. This is the same as the term in the second term for the numerator, 9. So that means the numerator for this nth term is going to be 11 minus n. And for the denominator now, 3, 4, 5, 6, 7. We're adding 1 now. So for the nth term formula we initially get is Tn equals to n. Now we have a 3 in the denominator. So to turn 1 into a 3, we can add a 2 over here. So T1 would be 1 plus 2, which is 3. T2 would be 2 plus 2, which is 4, and so on. So that means the denominator is n plus 2. So 11 minus n over n plus 2 is the nth term for sequence B. Now moving on to the third sequence. In the third sequence, if we notice, they're all even numbers. And we know that 4 is 2 square, 8 is 2 cube, 16 is 2 to the power 4, 32 is 2 to the power of 5, and 64 is 2 to the power of 6. All of these are powers of 2. So that means we can assume that it's 2 to the power of n. Now 2 to the power of n, if we start with the first term, that would give us 2, not 4. Hence, it needs to be n plus 1. Because 1 plus 1, 2. So 2 to the power of 2 would be 4. If you put n equals to 2, 2 plus 1, 3. 2 to the power of 3 would give us 8. So 2 to the power of n plus 1 is our nth term for sequence C. For this, you need to be very familiar with what is the difference between your linear sequence, quadratic sequence, cubic sequence. You need to be able to recognize the pattern, what is happening when it's a fraction, what is happening when an index. So for this, you need to be very alert when solving these questions. One small mistake will not give you the right answer. Question 14 says f of x is 5 minus 4x. Find f of -3. So you just substitute the domain in the equation. So f of -3 is going to be 5 minus 4 times -3, which is 5 plus 12, and that's 17. Then find f of 3 minus 2x. So if you compare the original function and this function, you can see that the difference is in x. The domain was initially x, and now the domain is 3 minus 2x, which means anywhere where it's written x in the function, you will replace that with 3 minus 2x now. So that's 5 minus 12 plus 8x. 5 minus 12 is -7. So -7 plus 8x is your function in its simplest form. Then find the inverse of f of x. So first you begin with putting the function equal to y. Right now the subject of the equation is y. We need to make x the subject. So to make x the subject, first I'm going to swap y with 4x. So that's 4x equals to 5 minus y. The reason why I swapped them and not move the 5 to the other side is because my goal is that when I'm trying to make a variable the subject, I want it to be positive from the first step. I don't want it to be negative. So that would make my calculation easier. So that's why to make x positive, I swapped it with y. So now we have 4x equals to 5 minus y. Now I'm going to divide both sides by 4. So x is going to be 5 minus y over 4. Last step is to replace x with f inverse x and y with x. So this is your inverse of the function 5 minus 4x. Question 15 says Virat records the height of each of 80 sunflowers. The results are shown in the table. Calculate an estimate of the mean height. So when we have group data, you basically have to first begin with finding the midpoint of each of the class intervals, because those midpoints are going to be your x values for the given frequencies. So what's going to be the midpoint of 1.5 and 1.2? So what you do is you add the maximum and minimum value, and then you divide the result by 2. So for the first interval, we're going to get 1.35. Then for the second interval, it's going to be 1.55. For this one, it's going to be 1.65. And this is going to be 1.8. So these are our midpoints for the given intervals. Now, mean has the formula of sigma fx over sigma f. Sigma means sum. So sum of fx means you multiply the frequency and the x value for each category, the interval, and then you add them up. So that's going to look like 1.35 times 12 plus 1.55 times 20 plus 1.65 times 34 and then 1.8 times 14. This is your sigma fx, and then you divide it by sigma f, which is the sum of frequencies. Sum of frequencies is already given in the question as 80, so you just write it as it is. So what we get is 128.5 divided by 80. That would give us 1.61. That is your estimate of the mean height. Then it says draw a histogram to show the information in the table. So for a histogram, we need the frequency density. So frequency density has the formula of frequency over class width. So for the first one, frequency is 12. Class width is the difference between the upper bound and lower bound of the interval. So 1.5 minus 1.2 is 0.3. And for the other one, we do 20 divided by 0.1. Then 34 divided by 0.1 and 14 divided by 0.2. So 12 divided by 0.3 is going to give us 40. 20 divided by 0.1 is going to give us 200. This is 340. And this is going to be 70. So these are our frequency density values. Okay, so from 1.2 to 1.5, it's 40. So 1, 2, 3, 4. So 10, 20, 30, 40. That's this one. So this is our bar for this. Then it's 200. That is your bar for 1.5 to 1.6. Then 340. 10, 20, 30, 40. That's your bar for 340 from 1.6 to 1.7. And lastly, 70. This is our bar for that. So this is your histogram. And remember the frequency density formula is frequency over class width. Class width is your difference between the upper bound and lower bound of the class interval. You subtract those, and that is your class width, and frequency is already given in the question. Question 16 says the graph shows the speed of a cyclist during a journey of 30 seconds. Write down the acceleration of the cyclist between 15 seconds and 25 seconds. So between 15 seconds and 25 seconds, your speed is constant. So when there's constant speed, that means there is no acceleration. So it's 0. If you notice over here, this is 15 and this is 25. It's a straight line. Constant speed at 8 meters per second. Constant speed means 0 acceleration. Constant speed at 8 meters per second. So 0 acceleration. By drawing a tangent, find an estimate for the acceleration of the cyclist at 7.5 seconds. 7.5 is going to come at, this is 6, this is 7, so this is 7.5. So we have to draw a tangent at this point. This is a tangent. So now we have to find the gradient of the tangent because acceleration is basically your slope of a speed time graph. And since the speed time graph at this point is a curve, so gradient of the curve is the same as the gradient of the tangent. That's why they're asking us to calculate the gradient of the tangent because that would give us the estimate for the acceleration. So you have to pick 2 points on this line and preferably whole numbers. So I'm going to pick this point and this point. So the coordinates for this point are 8 and 10 point. This and this one is this and this. So this is 10.05 and 8 because each small square represents 0.5. So this would be, sorry, this is 10.5. Yeah. Each small square represents 0.5. So this is 10.5, and this one is 1, 2, 2.5, 3. Yeah, this is 2.5, and this is, for the y-axis, your scale is each small square represents 2. This is 2.2468. This is 3. 3.24684. Then 4.2468. 5.8. 5.6. This is 5.6. Yeah. Okay, so on the y-axis, the scale is that each small square represents 2 units. And the x-axis, the scale is that each small square represents 0.5. So the coordinates for this point are 2.5 and 5.6. So gradient is going to be 8 minus 5.6 divided by 10.5 minus 2.5. So what I'm getting is 2.4 divided by 8. I'm getting an acceleration of 0.3 meter per second squared. That is my estimate. Then work out the average speed of the cyclist between 15 seconds and 30 seconds. So for the average speed, what we need is the total distance and the total time. So between 15 and 30 seconds. So this is our focus area. So we need the distance for this time period and we need the time for this time period to find the average speed. So for the distance, in a speed time graph, your distance is your area under the graph. So we need to find this shaded area. So if we look at the shape that it's making from 15 to 30 seconds, we can see that it's a trapezium. In a trapezium, we have two parallel sides. So that is our two parallel sides. And our height is 8. So height is 8. Parallel sides are, A is going to be from 15 to 30. So one is 15. So this length is 15 and this length is from 15 to, let me use a different color. 15 to 25, so that's 10. So 10 centimeters over here, 15 centimeters over here. So if we come down, area would be 1 over 2 times 8 times 15 plus 10. Area of a trapezium has the formula of 1 over 2 times the height, which is the perpendicular height, times the sum of parallel sides. So that's 4 times 25, and that's 100 meters. So this is your distance. Now time is between 15 to 30 seconds, so that's 15 seconds. So average speed is distance over time. Distance for that time period is 100, and this is 15. So 100 divided by 15 is going to be 6.6 recurring, so 6.67. meter per second. That is the average speed that I'm getting. Question 17 says the diagram shows 3 points A, B, and C on horizontal ground. The bearing of C from A is 145 degrees. So that means this is 145 degrees. And the angle ACB is 38. AC is 65 and BC is 95. And BC is 95. Find the bearing of B from C. So basically, they want us to find this angle. This is the bearing of B from C. In bearing, you always measure the bearing from the north in clockwise direction towards the line that connects both the points that we're talking about. Over here, it's point B and C. This is the north of C, with going in clockwise direction towards the line that connects B and C. And if it says find the bearing of B from C, so you measure the bearing from point C, not from point B. So now that we've established what we're trying to find, if this is 145, what you need to remember is that when you have parallel lines, these knots are parallel. So in parallel lines, alternate angles are equal to each other. So if this angle above the line is 145, so if this angle above the line AC is 145, below the line it's also going to be 145. Once again, alternate angles in parallel lines are equal. So if this is 145, this is a straight line angle, this is 180. So your bearing is going to be 180 plus 145, which equals to 325 degrees. In bearing, remember you always write your bearing as a 3-digit number. It's never written as 2-digit. Like for example, if you had the bearing of 25, you won't write 25, you'll write 025. So 325 is the bearing over here of B from C. For this, you need to remember 3 things. First thing, that the knots are parallel when you're comparing 2 points. Then, in parallel lines, alternate angles are equal. So the angle at the top of the line that connects the 2 points is going to be the same as the angle below that line. That's why the angle at the bottom of the line AC was also 145, as long as it's connected with the parallel line. And after that, remember that if the bearing is a 2-digit or a 1-digit number, like for example, it's 30 degrees or like 1 degree, you will always write it as a 3-digit number by adding zeros before it. So these are the 3 key rules for bearings. Then show that AB is 59.3 meters correct to 1 decimal place. So to find AB, we can see that in this triangle, we have 2 lengths and the angle between them. So whenever we have 2 lengths and the angle between them, that means we can easily use cosine rule to find the third length. So AB is the same as 65 square plus 95 square minus 2 times 65 times 95 times cos of 38. So if you bring this down over here, AB square. So AB square is going to be 13,250 minus, you find the product of this entire thing in one go. So 2 times 65 times 95 times cos of 38. That's 9,731.93. Find the difference of the two. 35,118.07. Take the square root of both sides, and AB will equal to 59.3 meters correct to 1 decimal place. That's exactly what they wanted us to prove. Then it says angle BAC is obtuse. Work out the bearing of B from A. Work out the bearing of B from A. So they want this. So we already know that this angle is 145. We need to find this angle in the middle. So this turned out to be 59.3. So if you remember, whenever in a triangle we have one complete set of angle and, opposite length, in this case, that being 59.3 and angle C, we have the angle and length. So what we can do is to find another missing angle or length, we can use the sine rule. Because in the sine rule, we need the one complete set for us to apply it. Over here, we are trying to find this angle to find the bearing of B from A. So we have the length for this angle. We have the complete set of angle and length, so we can easily use sine rule to find angle A over here. So that's going to be 95 over sine of angle A equals to 59.3 over sine of 38. So 95 times sine 38 divided by 59.3 is equal to sine of angle A. 95 times sine 38 divided by 59.3 is 0.9863. Now you find the sine inverse of this, and that's going to give us 80.5 degrees. Now the question that BAC is obtuse, so that means we will do 180 minus 80.5 to find the obtuse angle, because 80.5 is acute, it's less than 90. So that's 99.5. So this is 99.5 degrees. So bearing will be 145 plus 99.5, which is 244.5 degrees. That is the bearing of B from A. That's your answer. Question 18 says factorize 18a square minus 98. So we need to see whether there's a highest common factor between 18 and 98. So 18 and 98 both come in the 2 times table. They do not come in the 9 times table, the 3 times table, or the 6 times table. So that means we can only take 2 common over here. So 2 bracket 9a square minus 49. Now this still isn't fully factorized. Why? Because if you look at the terms inside the bracket, we can see that we have 2 squares being subtracted. And that reminds us of difference of perfect squares. In difference of perfect squares, you have 2 square numbers being subtracted. So 9 is a square number, 9 is 3 square. A is already being squared, and 49 is also 7 square. So that means we can rewrite this as 3a minus 7 times 3a plus 7. Why? Because difference of perfect squares says that a square minus b square is the same as a minus b times a plus b. Hence, 9a square minus 49 is the same as 3a minus 7 times 3a plus 7. So this is your fully factorized answer. Then it says expand and simplify. So we have a triple bracket, so we need to expand this. Start with expanding the first 2 brackets and then multiply the result to the third bracket. So x times 2x is 2x squared. X times negative 1 is negative x. Positive 4 times 2x is 8x. Positive 4 times negative 1 is negative 4. So this gets multiplied to x minus 2. Simplify the first bracket. So 2x squared plus 7x minus 4. Now we multiply the third bracket with this one. So it's going to be 2x cubed minus 4x squared plus 7x squared minus 14x minus 4x minus 8. Collect the like terms. 2x cubed plus 3x squared minus 18x minus 8. This is your fully expanded and simplified answer for this triple bracket expansion. Question 19 says solve the equation 2 plus 5 cos x equals to 0, where the angle is between 0 and 360. So you'll first begin with taking the 2 to the other side. So 5 cos x equals to negative 2. Divide the negative 2 by 5. Then we take cos inverse of negative 2 over 5. That's going to give us 113.58 degrees. Now it says that the angle is between 0 and 360. So cos is positive in the first quadrant and in the last one, which means for the other angle, we'll do 360 minus 113.58, which is going to give us 246.42. So one angle for cos is 113.58 and the other is 246.42 degrees. Remember, you have to find the values where the trig ratio is positive. So it's not just positive like in the given value that you found, it is positive in other quadrants as well. Sine is positive in the first and the second quadrant. Tan is positive in the first and the third quadrant. Cosine is the first and the fourth quadrant. So you need to be very careful about that. Question 20 says a piece of metal has volume 1240 centimeter cube, correct to the nearest 20 centimeter cube. The mass of the piece of metal is 7800 grams, correct to the nearest 100 grams. Calculate the lower bound of the density of the metal. So density is mass over volume. Since they want the lower bound of the density, that means mass will be lower bound and volume would be upper bound. To get the lower bound in division, the numerator is always lower and the denominator is always upper. So for mass, lower bound of mass. So that's going to be degree of accuracy is 100. So first we divide the degree of accuracy by 2, which is 50 grams. So lower bound would be 7800 minus 50, which is going to give us 7750 grams. That is your lower bound for mass. Now for upper bound of volume, degree of accuracy is 20 centimeter cube. So we do 20 divided by 2, which is 10. So upper bound would be 1240 plus 10, which is 1250 centimeter cube. So density would be 7750 divided by 1250, and that gives us 6.2 grams per centimeter cube. That is the lower bound of the density. Twenty-one says OAB is a triangle. C is the midpoint of OA. OC is M, CB is N. E lies on AB and AE is to EB is 4:5. Find in terms of M and N the position vector of E, giving your answer in its simplest form. So we have to find the position vector of OE. This is what we need to find. E lies on AB and AE is to EB is 4:5. If C is the midpoint of OA, that means CA would also be M. So OA would be 2M. We can begin with finding OB. OB would be OC plus CB. OC is M and CB is N. So M plus N is OB. Then what I'm going to do is I'm going to find AB. AB is going to be OB minus OA. The reason I'm going to find AB is because I want to use that to figure out what AE and EB is, and then we're going to use that to find OE. So AB is OB minus OA, OB is M plus N, and OA is 2M. So that's going to be N minus M, that is AB. So AE is going to be 4/9 of AB. So that's 4/9 times N minus M, and EB is going to be 5/9 of AB. So that's 5/9 times N minus M. These vectors were created based on the given ratio. Remember, in ratios, you add the given values in the ratio for the denominator, and the numerator is the number that represents that term. So since AE is 4 in the ratio, so 4 comes in the numerator, and denominator will be 4 plus 5, which is 9. So 4/9 is the fraction for AE, and 5/9 is a fraction of EB. AE plus EB adds up to AB. So that means 4/9 of AB is AE, since AE lies on AB, and 5/9 of AB is EB. Now in the diagram, OE is this. So we can find OE by adding OA and AE because we have that, or we can also do OB plus BE. Either way, you'll get the same answer. So I'm going to do OE equals to OA plus AE. I'm going to choose that. So OA is given as 2M, and AE we found to be 4/9 times N minus M. So that's going to be 18M plus 4N minus 4M. I made the denominator same, which is 9, and expanded the bracket over here. So 18M minus 4M is going to be 14M plus 4N over 9. This is your vector OE, the position vector of E, in its simplest form. Question 22 says the line y equals to 4x plus 12 intersects the curve y equals to 2x squared minus x minus 3 at point P and point Q. Find the coordinates of P and Q. So a straight line intersecting a curve. So that means you put the y values equal to each other because the intersection point is the common point that both the line and the curve share. So 4x plus 12 equals to 2x squared minus x minus 3. Bring all the terms on one side. 2x squared minus x minus 4x minus 3 minus 12. That's 2x squared minus 5x minus 15. Now we're going to factorize this quadratic equation. So since it says the answer would be correct to 2 decimal places, that means we'll be applying the quadratic formula. Quadratic formula is x equals to negative b plus minus square root of b squared minus 4ac over 2a. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. So a is 2, b is negative 5, and c is negative 15. You always write the sign with the number. So it's going to be -5 plus minus square root of -5 square minus 4 times 2 times -15 over 2 times 2. That's 5 plus minus. That's 145 over 4. Square root of 145 is 12.04. So 5 plus minus 12.04 over 4. So 1x is 5 plus 12.04 over 4, which gives us 4.26. And the other is going to be 5 minus 12.04 over 4, which gives us -1.76. Now we need to find the corresponding y values as well. Now to find the corresponding y values at x equals to 4.26, y is 4 times 4.26 plus 12. The reason why I chose the linear equation to find the y value is because the calculation is going to be much simpler than substituting it in the quadratic equation. So 4 times 4.26 plus 12 is 29.04. And then at x equals to -1.76, y is going to be 4 times -1.76 plus 12, which is 4.96. So your coordinates are 4.26, 29.04 for the first one, and then -1.76 and 4.96 for the other one. So we call this Q and P. Question 23 says diagram shows the major segment of a circle, center 0, radius 2.5 meters. The segment is the cross section of a tunnel with height 3 meters. The length of the tunnel is 1800 meters and it has the same cross section throughout its length. Calculate the volume of the tunnel. So we have a major segment of a circle with center O and radius 2.5. So that means this is also 2.5. This length is also 2.5. So if this entire length is 2.5 because it's the radius, it's coming from the center and going towards the circumference, this is 0.5. 3 minus 2.5 is 0.5. They said that the length of the tunnel is 800 meters and has the same cross-section throughout its length. So for the volume, basically, we need the cross-section area right now. So if you look at the division that I've made, we have this triangle over here. And inside this non-right angle triangle, we have created this right angle triangle as well, where the height of the triangle is 0.5 and the hypotenuse is 2.5. So what we can do is, using this information, we can first find this angle over here, and that will further help us in identifying the area of the segment as well. So let's first find the angle. So we have the hypotenuse, we have the adjacent, so cos theta would be 0.5 over 2.5. So we find cos inverse of 0.5 over 2.5. That's going to give us 78.46. That is our angle over here, this. So complete angle would be 78.46 times 2, which is 156.92 degrees. That is our angle. So the angle outside, that's going to be 360 minus 156.92. That's 203.08 degrees. Okay, now that we have our angle sorted for the cross section, what we can do is we can find the area of the major segment that's at the top with the angle 203.08, and then we can find the area of the triangle at the bottom using the area of the triangle formula because we have the angle for that as well. So area of sector would be 203.08 divided by 360 times pi times r square. Radius is the same, 2.5 square. So that's going to give us 203.08 divided by 360 times pi times 2.5 square, 11.076 centimeters square. Then area of triangle 1/2 times 2.5 squared, because for this formula we need two lengths and the angle between them. The two lengths are 2.5 because this is also 2.5, and then sine of angle 156.92. That's going to give us 1.225 centimeters square. So I'm going to remove this part. So total area is going to be 11.076 plus 1.225. That is 12.301 centimeters square. So volume will be cross-section area, which is 12.301, times the total length of the tunnel, which is 800. That's 9,840.8 meter cube. That is your volume of the tunnel.